The Big Bang Theory is one of the most important theories in cosmology and the most widely accepted theory on how the universe began. The Big Bang tries to explain what happened at the beginning of the universe and how the universe is evolving. It states that all of the current and past matter and energy came into existence at the same time. Roughly 13.73 billion years ago, all the matter was compacted into a ball with unbelievable density and intense heat and began to expand, creating our universe. This theory was first discovered by George Lemaitre, in which he named the hypothesis of the primeval atom. A common misconception of the Big Bang Theory is that it began with an explosion. However, the Big Bang was more of an expansion. As time passed, the universe began to expand. At first, during the Big Bang's inflation period, the universe expanded extremely fast, and galaxies were close together and photon wavelengths were shorter. As time went along, the universe became cooler and less dense. The universe is expanding at an equal rate in all directions. This is how the theory explains Hubble's law and redshifts. Redshifts are caused by the expanding space. The farther away a galaxy is, the more that galaxy is redshifting, and the faster it is moving away from us. The galaxy's wavelength is becoming longer, and its redshift is becoming more and more red. This is also shown in Hubble's law, which states that velocity is proportional to distance, and in current time, Hubble's constant is 71 kilometers per second. This is the constant rate at which the universe is expanding. Redshifts are shown by these two wavelengths. As galaxies become farther and farther away, their wavelengths become longer and more red. As galaxies become closer, their wavelengths become shorter and are shown by becoming more blue. As you can see in this Hubble diagram, velocity is paired against distance. The line indicates Hubble's law, and each black dot is a galaxy. As you can see, the farther and faster a galaxy is traveling, the more it is likely to fall below the line. This indicates that the universe is expanding. The Big Bang Theory is backed by CMB. CMB, or cosmic microwave background, was first discovered by Arnaud Penzias and Robert Wilson in 1964. CMB is a microwave light radiation that is equivalent in all directions and was left over from the hot early universe. It was a result of decoupling and recombination in the universe. Recombination occurs when free electrons combine with nuclei, forming hydrogen, leaving protons to roam freely. Decoupling is the result of the photons not interacting with anything but the warm temperature, creating the cosmic microwave background. Cosmic microwave background is a perfect blackbody. It indicates the temperature of the CMB as 2.725 degrees Kelvin. This is an all-sky image of cosmic background radiation. The red spots are warmer and can range up to 4 Kelvin, while the cooler blue spots can be as low as 0 Kelvin, averaging out the CMB to be 2.725 Kelvin. The Big Bang allows for an abundance of light elements. In the first few minutes of the Big Bang, nuclear fission was able to occur due to the extremely hot temperatures. Nuclear fission created the light elements. We can determine which elements are in the universe by measuring the reaction rates for deuterium, which is one of the few elements that is stable after nuclear fission takes place. We found 7 protons for every neutron. When 2 protons combined and 2 neutrons combined, helium was created. The remaining 12 protons were hydrogen. This leaves an abundance of 25% helium and 75% hydrogen. Heavier elements throughout nuclear fission could not be stable. After inflation and recombination occurred and TMB had been released, the period of the Dark Ages began. Hydrogen was the only light source during this period, and it lasted for the first 150 to 850 million years. After the Dark Ages was reionization, which lasted until 1 billion years. Here's where the first stars and quasars formed. After reionization came the introduction of galaxies and eventually planets, continuing the expansion. Olber's paradox is backed by the Big Bang theory. The Big Bang shows that the universe is finite. The universe has a beginning and will also have an end. Light will only reach as far as the horizons. The reason why the sky is not completely lit up at night is because the light is too weak and has died out before it has reached Earth, and light has been redshifting away from us. Also, the Big Bang leaves room for dark matter to exist. The Big Bang theory is an explanation of what happened during the beginning of our universe. It is backed by redshifts, cosmic microwave background, the light elements, and Olber's paradox. Even though the Big Bang theory is the most widely accepted theory among astronomers, some still believe in other theories, such as the steady-state theory.